We will continue today 1244 of the Heidegger series, and I continue with the book by Roberto Mangabeira, Unger and Smolin, A Single Universe. Reason for I'm continuing for such a long time is that I want to let it sink in properly. It is very, very important breakthrough for humanity, I would say. Sounds like a bit of an exaggeration, but I vouch it is not. This is one of the most important things I ever read. But it's a very thin line between what is completely nonsensical or non-important and what is important in this case. Very hard. My general feeling here is that normally in philosophy we really exaggerate a bit to make it juicy, telling, important, knowledgeable. But in this case, when the message isn't so important, the real acuteness and delicateness is in itself very important. Those are the telling things what it is really about. So let me cut to the chase and get right into it, but first a puff on the pipe. I hope these really reach you in a good mood. I'm in a good mood. This is something of a boon at this time of year. We are counting the 9th of November. Must be very close to Guy Fawkes Day. Remember that night in November. I don't recall the whole rhyme, but it's sometime in November. Now sooner do we begin to subvert the distinction between initial conditions and laws applicable to particular configuration spaces by generalizing the terrain of its application to the whole of the universe. Then we are forced to question the idea of timeless laws governing a world, the elementary structure of which is also timeless. So the point here is mathematics is timeless, and that in itself is part both of the solution, but what Roberto Unger is pointing out here, it's a problem as well. Particular sciences report to us that the way in which things change also changes. For example, life on Earth introduces a new set of mechanisms of change. Which in turn keep changing. The idea of timeless laws begins to seem a convenience or an approximation. That remains plausible and useful only so long as we focus on one configuration space at a time. Cosmology is the part of physics in which we are brought up short in trying to preserve these two connected contrasts. Between stipulated initial conditions and the law-like workings of nature, as well as between space-time and the timeless and universal laws of nature. The issue is whether we should think of the breakdown within cosmology of these two related distinctions as an exception, or a limiting situation peculiar to science, or on the contrary, as a revelation of truths relevant to all science and all nature. We here offer reasons to take the cosmological perspective, the view from the stars, as it were, as a paradigm rather than as a peculiarity. If our argument is correct, the overturning of the distinction between the events and their backdrop in space and time which mark the physics of the first half of the 20th century should now be followed in the first half of the 20th century by the overcoming of the two related contrasts that were reaffirmed when that one was demolished. the method of distinguishing between initial conditions and law-like explanation within a configuration space should be recognized to be the less legitimate, the more it is universalized. It is an expedient that depends for its legitimacy on the localism of its applications. The contrast between the physical manifold of events, space, and time and a set of unchanging laws, symmetries, and constants should be undermined. The laws of nature, as well as its symmetries and apparent constants, should be included in the history of the universe, rather than placed outside it. Just as space and time cease to be represented by the new physics of the early 20th century as an independent and absolute background to natural phenomena. This is an agenda for the future of science. It suggests, however, a reinterpretation of its past. Which in turn helps shed light on what we can and should do next. a standard view of the history of physics over the last 150 years distinguishes the main line of intellectual advance from what has been largely seen as a sideline. At the source of both the putative main line and the supposed sideline lies the combination of Newton's mechanics with Clerk Maxwell's electrodynamics. Consistent with Newton, as well as with Maxwell's non-Newtonian conception of fields. The unification of Newton's and Maxwell's equations in the early 20th century shaped the course on which physics has remained ever since. The quest for a view capable of unifying the theoretical treatment of the basic forces at work in nature. According to the dominant interpretation of the history of physics, the main line is the one that goes from Newton and Maxwell to contemporary string theory by two distinct routes. One route is special relativity, followed by general relativity, the other route is quantum theory, followed by the standard model of particle physics, as well as by the theoretical foundations of this model, including quantum chromodynamics and electroweak theory. On the same interpretation, the sideline is the theoretical succession that goes from thermodynamics that is before it was given atomic foundations, to Maxwell, to an atomically founded thermodynamics, from there to Boltzmann's kinetic theory and statistical mechanics. Remarkably, in this narrative of the history of physics over the last century and a half, otherwise so obsessed with the unification of theory, no clear link exists between the progress of the main line and the advance of the sideline. The difference between the two histories is often trivialized as a distinction between the macroscopic study of the ultimate constituents of nature, the main line, and the macroscopic study of aggregate phenomena, the sideline. The divergence between the main line and the sideline was foreshadowed in the founding pair of Newton and Maxwell. Newton and Maxwell were reconciled. Nevertheless, what distinguished the sideline from the main line sprung directly from Maxwell's discoveries and ideas. In fact, the two lines have harbored contrasting approaches to some of the problems central to the argument of this book. In the main line, time began by being treated as part of the absolute backdrop to physical events. When it was later promoted from the scenery to a performing part, it was still assigned a role accessory to the role granted to space. general relativity under its most influential interpretations was more inclined to spatialize time than to temporalize space. As the geometrical metaphor of time as the fourth dimension suggests. The willingness to see mathematics with its core focus on number and on space as a vehicle of privileged access to fundamental and hidden truths about nature only reinforced the anti-temporal bias. In the sideline, however, the opposite took place. The understanding of time, real time, going all the way down and including everything was given a real basis in the directional force of entropy and in the account of the workings of nature, of which the concept of entropy formed part. That the sign line has a claim to be taken as least as fundamental in its significance and as general in its scope of application as the theories generated in the main line was presaged by an incident in the history of physics whose significance has gone largely unrecognized. Einstein's demonstration in the arguments for special relativity of the primacy of the so-called Lorentz transformation show that Maxwell did not deserve to be treated as the junior partner to Newton. Einstein taught that the coordinate transformation that held the Maxwell equations constant rather than the one that preserved the Newtonian equations was the most general and reliable transformation. Newtonian mechanics, however powerful, had to be reinterpreted as the theory of a limiting case. A revisionist reading of the history of physics would seek inspiration for a historical way of thinking about the universe. In the line that begins in thermodynamics before Maxwell, continues in thermodynamics after him, and leads to the contemporary study of cosmological difficulties such as the so-called horizon and flatness problems. It is a recessive strand in the past of physics that could become dominant in its future. In that strand, time is not accessory to space. Events are not time symmetrical. The historical character of natural reality is not an accidental or peculiar feature of a certain sets of aggregate phenomena. It's an attribute of the one real universe. One, 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 one. The analysis of microscopic structure is no substitute for the explanation of macroscopic history.